Yeah, that's it. Let's start. We have very less people today, but let's start. Hopefully, more will join later. Okay, so we have briefly saw what cognitive, what learning and memory part is in the previous session, and so we'll just revise quickly what we saw before. So first of all, we saw that there are three types of memories, basically sensory memory, short-term memory, and long-term memory. All right. And we get the input from our senses, basically any of the five senses: eyes, nose, ears, taste and touch. And depending on how our attention is divided, that data is carried on to the short-term memory, and over there again it stays for some 10 to 20 seconds. And depending on how much importance we give to that data, it is stored in the long-term memory, or else it is lost. And that's how it works. Encoding is basically storing the data from short term to long term, and that's how this basically works. And today we are going to see a little bit deeper in this topic. So yeah, let's start. uh, so the very first thing is the three domains of learning, and this person Benjamin Bloom found it in 1965. Now we'll directly jump into what the model is about. Okay. So the three domains of learning are basically cognitive, psychomotor, and affective. So what are these? Let's take an example. Okay, so suppose you are learning a new language. Suppose you are learning Hindi for the first time. In that case, what will happen? You will first of all you will try to understand the basics of Hindi, right? Like how the letters are written, how the grammar works, and all of that. So that is the cognitive part, in which you just try to understand the thing that you are trying to learn. Take it language, taking riding a cycle, take it learning to code, whatever. Now next step comes is the psychomotor part. Now suppose you have like cleared all your basics of Hindi, you know what grammar is, you know how Hindi letters how we write the Hindi shabd. And so in this part we'll actually learn to write with a pen first, because we can't write without learning to write. Okay, so we'll learn how to hold a pen, how to write with the pen on a paper with properly, according to the lines. That is the psychomotor skill. And once we learn to write, we can basically do it with ease all our life, right? Kids cannot write that easily. They write in a random way because they don't know. They have not learned the psychomotor part of writing. So that's the psychomotor. Basically, you can divide it into two parts. Psycho means the psychology of it, and motor means uh, the muscle memory, what we call. And the next part is effective. Now suppose you know Hindi, you have learned the basics, you know how to write Hindi very properly. Now you come across an Hindi poetry and you read it, and you realize that okay, this is very quite beautiful. So you explore more poetries, and you understand, you realize that you have fallen in love with the language itself. That is effective learning. That means loving something, hating something, worship, appreciation, all that comes under the third domain, that is learning. Okay. Now I hope that example makes it clear. So now the one thing we need to note here is that in the three domains of learning, one can lead to another, and it's not like if cognitive is different and psychomotor is different. And how let's see how that works with an example. Okay, so yeah, so let's take an example of let's take the example of a chess game. Okay, so first of all you need to know the rules again here. Okay, you need to know how to play chess, how the pieces work. And once you know that clearly, after next step is you will basically start to actually move the pieces, and play out your tricks, your strategies. And slowly you might develop the love for the game, and you might develop the way of looking at life depending on the game, like how chess masters see it. That is how one thing can lead to another. The psychomotor skill can lead to affection, or the basic skill, or out of all these three skills, each one can lead to another. Now some new people have joined right now, so I'll just quickly brief what we have just started. We just went through the basic quick revision of how memory works, as we have seen in the previous section. Sensory input goes to the short-term memory, and then short-term memory goes to long-term memory, and it all depends on our attention, how attention works. If our attention is not there on certain data, it will get lost. Now, after that, we saw that Benjamin Bloom is basically developed this learning, these three domains of learning, and those are these three: cognitive, psychomotor, and affective. And cognitive basically means to mentally learn something, to learn a new language, to learn the rules of chess. Then psychomotor is basically learning to write, or learning to actually move the pieces, or learning to play an instrument. Then affective is to actually to develop the emotions for some certain thing, like loving a language, loving a game, etc. Now, one thing can lead to another. That is what basically means not mutually exclusive. And so the next thing is the three storage systems of memory that we have already seen briefly in the previous section. Now we'll see a little more technical details regarding these. So the basic structure is, as we know, sensory memory. Then, according to our attention, that goes to the short-term memory. And just a second. Yeah, exactly, Jyoti. Cognitive is head, means thinking, affective is heart, feeling, and psychomotor is hands or muscles that is doing. Perfect. That's a very good way of putting it. Okay. So yeah, depending on our attention, the data is transferred from sensory memory to short-term memory, and after from short-term memory to long-term memory. Okay. Now in the sensory memory, the memory lasts for only like about very few seconds, 2 to 3 seconds maximum. And in the short-term memory, memory lasts for 3 to 20 seconds, and it is vulnerable to interruption. What does this mean? Suppose suppose that you are told to, someone says you that I am telling you a number, try to remember it, and at the same time there's a loud music playing somewhere around, so you might not be able to remember that number efficiently, because your short-term memory is getting basically interrupted because of the sound that is playing around. Okay, so that is what basically is meant by vulnerable to interruption. And the long-term memory, in this, the meanings and emotions are play a very vital role in what will be stored in the long term and what will be discarded, or go out of our access. Now, long-term memory also affects our perception, because whatever we perceive out there depends on what we have already perceived in our whole lifespan till now. And the more we rehearse things, the more it is better, it is good for storage in the long term. For example, if you are suppose learning some chapter from cognitive psychology or some specific topic, then you might remember it very well if you try to not only like read and understand it, but also try to explain it to other people, or just discuss that topic with many different people. That will help your long-term memory. So this can be used as a hack to remember things during exams, or understand things in general. Okay. Now in sensory short-term and long-term memory, we have certain technical terms that we'll look into now. Now first of all, in sensory memory, we have something called as transduction of memory, and it is very not tough. The word looks a little bit confusing, but it is not. So transduction means changing from one form to another, and so the whole phrase basically means that transform, like changing one form of energy to another form of energy, right? So that is what happens at the sensory memory level. Now suppose we are smelling something. So what happens when we smell is basically the molecules go into our nose, and we have certain special cell receptors. Those cell receptors do the work of taking the data from the outer world and converting it to a language that our brain understands, that which basically means electricity, or nerve impulses, right? So that is what happens here, and after those are converted, those are sent to the brain centers which are responsible for that particular sense, and after that comes a reaction like the smell is good, the smell is bad, etc. One more example that we can take for the same thing is food. We have all sorts of food around us, but whatever we eat, it basically gets converted to the basic elements of our body, right? Proteins, vitamins, minerals, fats, etc. And those are then used by our body to keep rebuilding and repairing itself. So we don't really look like this, do we? No, right? So that is what conversion of energy is on the level of food. We eat whatever we can, but it gets converted to the basic things that our body works on. The same happens on the level of the brain. The senses take whatever they can, whatever comes in their way, and that is basically converted to our brain in a language of our brain and is sent to it, and then it processes it further. So that's what transduction of energy means. That means conversion of one energy to another. As simple as that. Now, uh, the next thing is Miller's magical number, and best way to understand this concept is to learn it through a quick game. So you don't need to do anything. You just have to have your phone in your hand, and you will need to type something in the chat. That's it. So how to play it? First of all, I'll show a number on the next slide, and like I'll show that slide for 2 to 3 seconds, and after that you will need to type the numbers that you remember in that. Okay, there's nothing right or wrong, winning or losing. You just have to participate. It's a good way to understand this. So I'll show the slide now and try to remember how many numbers you can, and type it in the chat after you see this after the slide is changed. This is a number, try to remember it. Okay, now type it in the chat. Whatever numbers you remember, type it. I hope everyone is participating here. Okay, Aisha 757658, nice. Nobody else is participating. This is the best way to understand these concepts. Come on. Okay, 78524. Okay, nice. The number is close. 785246. Very nice. Okay, we got 3 people. Thank you for participating. Now let's do the same thing in a different way. Okay, so I'll again show a slide slightly differently, and again try to remember as much numbers as you can and type it in the chat. Okay, type it in the chat right now. Numbers increased, yeah, right, yeah. Okay, so as you can see in the chat, the amount of number that you remember increased, right? Yeah, right, Munish. Yeah, exactly. So that is what this concept of Miller's magical number is, right? So what Miller said, this guy said that our working capacity or a short-term memory can hold numbers only around 7, either plus 2 or minus, more than like 8, 9 or around 5, uh, not more or less than that. So what did we see right now? We saw a bunch of number together, and the amount that we remembered was very less. But after that, when we divided it into chunks, we were able to remember a very much better in a much better way. So his mic is on. Linda, can you please mute? I can mute now. Thank you. Okay, so yeah, Miller's magical number. So what it basically means, so those who are from a computer background might know that we calculate memory in the terms of bits, right? Like one number is 1 bit, second number is 2 bits, etc. So what Miller said is that the way a short-term memory works, it doesn't really work in the form of bits. Rather, it works in the form of chunks. And what are chunks? That we'll see like properly in the further slides. But chunks are the basic example was the numbers when we divided it into small parts. Those are called chunks, and we can store.
ഞാൻ അഭ്യാസത്തിന്
we can store basically 7 chunks of data, and how those chunks work, that we'll see further. Okay, so Miller's magical number basically says that the 7 is the number that is stored in a that is a capacity of a short-term memory, plus or minus 2, not more or less than that. Okay, now let's go further. Now let's see the three operations of short-term memory. These are like basic things, not too tough. So iconic memory is basically the memory of a the memory of the visual memory, okay, or visual memory. The second is the acoustic. Acoustic basically means the memory of our sound, the sound memory or the memories of our ear. And the working memory can be compared to the memory of our RAM in the computer or phone, the memory that is used for the current task. For example, if you want to remember a phone number, you will repeat that phone number to yourself, right? That is the working memory at work there. And those who might not understand what a RAM is, so when your phone is hanged, what do? You try to restart it and it works properly, right? So basically, you are basically cleaning the working memory of your phone, and that is what is meant by RAM, and that is what the same concept is applied here. The working memory means the memory that is at work for the current task. That is the short-term memory of part of working. Now, now let's understand what are chunks, chunking or chunks. So it is a long-term memory concept because it helps us to retain to store data efficiently in the long-term memory. And also when it comes to long-term memory, we do not know what the limit is, because there's a certain mental condition where the person remembers each and every day of his life in detail, like we don't remember it as much. We remember only certain incidences which were which impacted us in certain way, but there's a certain mental condition. So basically, we do not know the limit of a long-term memory. We just can't really recall all of it, but we don't know how much it can store because it is pretty huge, right? So yeah, let's understand chunking. As you can see here, the unchunked list is basically just random words, okay? Bread, ice cream, milk, tomatoes, eggs, butter, etc. And if you try to store this list in your long term, it might not be as efficient as storing it in this way. When you basically divide it in different sections, like frozen foods is ice cream and frozen peas, dairy is milk, eggs, cream, butter, etc. Screen is not clear. Ah, okay. That photo is actually a little bit. Okay, just a second. I'll just say what that is. Okay, that picture is not clear a little bit. So the screen, the list on the left side, what it has is it has basically different words like bread, ice cream, milk, tomatoes, eggs, butter, apples, etc. And the list on the right side, it has the same words, but it is basically organized in categories. Like in frozen foods, we have ice cream and frozen peas. Then below that we have dairy, and in dairy we have milk, eggs, cream, butter. Below that is bakery, which includes English muffins, bread, bagels, etc. Below that is fruits and vegetables. So this was just an example to show that if you want to store data in the long-term memory in an efficient way, then it is better to do this using this method of chunking, or basically dividing the data in various parts, rather than just randomly trying to store words that have no connection to each other, because it will be tough, and it applies to all the things. Even learning is based on this only. If you try to just rattamaru all of it, all of the basically data, or the subject, then it might work for a short time, but you might not really remember it after a while. We have all gone through in the school, right? So yeah, chunking is basically dividing the data in short parts and making it sensible for our brain. So making it relatable, relating the data to each other, or you can get creative in this process actually. A mind map is also basically chunking of data. So yeah, chunking means that. And now let's move ahead. If you have any doubts, you can just turn on the mic and ask, or type in the chat. Now let's take a look at schemas. So schemas are basically mental models of the world, or mental models. Like for example, if someone says you a tree, the word tree, then it might bring all of these concepts up, right? So or the way our brain works is that it stores everything in connections, and it is deeply connected. Like for example, the example I gave last time of apple. If someone says apple, you might remember the basic properties of the apple, the color, the shape, the taste, etc. You might remember Newton, you might remember certain incident that happened with you where apple was included. You might remember some cartoon that had apple. Dude, it can go very far depending on how many incidences regarding apple had you had in your life, and how they are stored in your memory, or how much impact they had on you. So those are basically schemas, how the world outside is structured in our mental space. And yeah, that's how it works. If you basically, every single thing is basically connected to a lot of things. For example, over here we have tree, we have leaves, right? So these leaves will also in turn be connected to maybe color green, to the shape of the leaf. Then the color green might also be connected to some other, all the other things that are green. So in this way, it is like a chain reaction that happens when the memory is set to recall things. Okay, now the next thing, this is just something I observed while going through this whole second unit of memory. So those of you might know that the ancient of the all the text of Vedas, those were not written down till quite recently, right? Before that, they were basically like taught from the guru to the disciple, and they remembered all of those texts which are like way too vast. And if you try to just read any of the verse, you'll basically understand that the way the whole content of Vedas is designed, it is quite brilliant, because it takes in all these concepts of long-term memory, short-term memory, chunking, and helps us to remember those things. Because what we learn in a long-term memory, that knowledge that basically the importance that we give to the knowledge depends, like has an effect on how efficiently will it be stored. For example, uh, a disciple who is learning something or listening something from his guru will will by default have more importance and respect for that content, rather than reading it from a book directly, right? So that itself is a principle that is applied in the long-term memory storage. Next is reciting of those verses daily. That was also a daily task they had to do. That is also long-term memory hack, that we have to keep recalling, keep discussing the things that we have to remember in the long term. Then even in the short-term memory, we know that all those basically the different verses, they are all very poetic. If you read that, they are all very poetic and very short and very to point. They do not have extra grammar, extra unnecessary things, and that is very efficient way of storing things in our short-term memory first, because because the short-term memory, as we know, has very short parts, right? So, and even the verses are very small, or at least they are very efficiently divided into small chunks, and that really must have helped the remembering part. So yeah, I just added this because I noticed this while studying the content. And also the Sanskrit effect is basically a research done by certain researchers. What they did is that they recruited certain expert Vedic pandits, and scanned their brain. What they found was that many areas of their brain were consistently larger than an average brain, and all of those parts basically improve their cognitive functions, and especially the part that is related to learning, which is the hippocampus. So, and our brain is quite like flexible. It keeps growing if we depending on how we use it. So the source Sanskrit also has an effect on how our brain, how your memory storage works if you do it in the long term, of course. And yeah, that's just something I wanted to share. You can learn about this Sanskrit effect more. It is quite fascinating. Yeah, so now let's go to the next part, which is the theories of information processing. Okay. So we have two theories in this. First of all is the Bloom's taxonomy of cognitive development, the same guy. And what are these? And they have like 6 levels, and each the very lower level is basically very the basic remembering something the very basic way, and the top level basically means like knowing something in an expert way that you can use it to like create new things. We'll understand it in like via an example. But the left side that we see here, the left model, that is the original model that this guy created, Bloom, and the right one is the one that was like modified later, but and this one is like more in use in the current times. So we'll just you should know that you can be that question might be asked somewhere. So and the only difference is these two parts. Okay, the creating is replaced by the evaluation is replaced by creating, and the synthesis is replaced by evaluating, and the terms are replaced over here in the bottom. Knowledge is replaced by remembering, and remembering actually fits pretty well in this part. So let's take an example of how these things work. Okay, so can someone tell me how did you select a cake when you were when you went to a bakery and as a small child when you did not really understand the flavors and all? So you have all these different colors of cake, right? How did you select one?
By the appearance, the look, attractive look.
Yeah, exactly. Appearance, colors, right? Yeah. So exactly, we either remembered it by that वो गोल वाला केक चाहिए वो रेक्टेंगल वाला केक चाहिए और वो ग्रीन वाला या वो ब्राउन वाला केक चाहिए या पिंक येलो whatever. So that was the way we remembered it, right? So that resembles the first level of learning here, remembering. Remembering basically means to remember something by in a very shallow way, like the color of that thing or the shape of that thing. In our case, the cake, or just to remember the name or how it looks, not much detail, not knowing anything about it more than that. Now the next step is basically the next step is understanding. Understanding means suppose you grew up, okay, now you understand, now you are able to know a little bit more about cakes. So now you know that, okay, apart from the shape and the color, now you can also know the what ingredients are used. Now suppose you now know that this is a chocolate cake, and you also know that how that cake is made and all of that, so you have a much better understanding than this one, right? So that is understanding basically. The next part, then remembering, and after that comes applying. Now applying means to use all your knowledge. Suppose you know how to like how cake is made, how to give it a shape, how to give it the color. Now applying basically means to use all of that knowledge of cake and to actually make a cake. That is the next step of applying. And one thing that to note here is that if you like this is not an incremental thing like first you go to remembering, then understanding, then applying. It doesn't work like that. Suppose you are making a cake, and then you'll by default remember and understand about the details about the cake, right? So if you are doing any of the top things also, you will by automatically learn all the basic things about it. So it is not a incremental thing. It's like one thing can affect the other. Okay. So applying is clear, right? We can make a cake now with all the knowledge that we have gained. Now comes analyzing. Analyzing means to compare the knowledge of that particular thing of various how to put this, okay, so of comparing the knowledge of that different how different people make that thing. Basically in this case, like we know how to make a chocolate cake. Analyzing means to compare that how a pineapple cake is made, maybe blueberry cake is made, and to compare what are the ingredients, what are the differences, and how the process is same or different. That is the analyzing part. We basically upgrade a little bit more in the process. Now comes the evaluating part. Now you know different types of cake. You might also be able to make different types of cake. Evaluating basically means to compare the very details of each and every cake, like which cake tastes better, which cake is healthy, which cake uses more artificial ingredients, which cake doesn't, etc. Like you will really go into technical details of things. Creating is the topmost kind of learning according to this, and creating means to take all the knowledge of your of cake making, take all the knowledge of analyzing, and to finally make a cake that is not really made by anyone till now, to make like maybe a different shape, maybe a whole different flavor, etc. So that's how this all these steps work. The remembering is a very basic level. You can also call the rote learning part over here. Rote learning is basically remembering. We try to just read the thing and remember it. Doesn't work quite well. Understanding is to just go a step above, and applying is to go even above. And also, if we try to if we do any of the above things before before these, then we automatically also apply this, because suppose let's take another example. Okay, suppose that you are learning to like plant a tree, and you are basically applying the knowledge of planting a tree, but you don't remember, don't really know what kind of seeds are there, or what the kind of soil you are working with, etc., and how much water should you put in the initial stage, all of that. But you don't really need to remember all of this if you directly plant a tree, because that will automatically give like take all of those data and store it in your memory. So yeah, the things, yeah, all of these include like affect each other. Yeah, now let's go to the next step. uh, Sternberg's information processing model. Now this is another information processing model. This is not a memory storage model. This is more of an intelligence model. And as you can see, the three parts are meta components, performance components, and knowledge components, right? So what are these? Again, let's take an example. Okay, so let's take an example of a Diwali celebration. Suppose there is a Diwali coming, and you decide that you will be like making celebrating this Diwali quite in quite no in quite a big way by doing a get together of of all your family, like relatives and friends. So, and your family tells that okay, you will handle this task, you will manage the whole party. So first of all, what will you do? Okay, you will basically try to plan what to do. Okay, like what guests to call, what decoration to do, then how to assign different tasks to different family members, etc. All of these things till now are going on in your head. You are just planning, you are not applying anything. That planning, that mental decisions, or mental the decision to take actions, those are all meta components. That means the mental action that we take, the thinking, that you can put philosophy in this part, the thinking and processing information like before taking action. And performance components are basically to take action. Now that you know what to do, you know how to assign the task and all of that, you will now set to work. You will call the decorator, you will assign the task to different people in your family. Then then you will basically sorry okay so then you will basically start to yeah then you will also start to call the guests and all of that. You are basically taking actions now, and that is performance components. And the knowledge components is basically, suppose you did organize a party last year, and some of the guests actually spoiled the party. So you now know that those guests might spoil the party. So right now you will use that knowledge to not call those guests again, right? So that is basically knowledge components. That is deriving learnings from experiences and applying that to the current scenario. Knowledge components can be applied to the scientists who basically are quick to learn, who can learn lots of things quickly, and apply those to the problems that are there or that might arise. Okay, so these are basically these three components, and these are actually different types of intelligences, and there's also these are also sub part of a different model, but we don't have in that have that in our syllabus for some reason. And if you read about this, these will become clear. They are not much tough. This is basically thinking, this is action, this is learning from experiences. Okay, and that was it for today. Actually, we don't have the second module was not too big, the second unit. So please ask any questions if you have in the chat, or you can turn on the mic, no issue.